The biggest two topics in Chapter 8 are graphing trig functions, a little bit more than we did in Chapter 7, and solving equations, which is what we're going to start with today. So for a warm-up, the first question here is sine theta equals 1/2. So what I want to know is, where does sine equal 1/2? Or in other words, using the notation we learned in Chapter 7, sine inverse of a half. So the question in white here says, how many places is sine positive from 0 to 360? Well, this we should be pretty good at by now, but if we take a look at the unit circle here, we know that sine is positive in quadrants 1 and 2. So that's what we're going to take into account when we go to answer our question. So knowing your first quadrant of your unit circle, or using the hand trick backwards, whatever your strategy is to do this, we know that sine theta equals 1/2 at 30 degrees. With these, the biggest thing, there's almost always going to be two answers for these. So we also need to take a look at the angle in quadrant 2 that has a reference angle of 30 degrees, or in other words, the other place where sine is 1/2. So our answers, we end up with 30 degrees and 150 degrees. If we take a look at this one, it's pretty similar. So we need cosine theta equals -1/2. What we notice here is now we're going from 0 to 2 pi, so we know our answers need to be in radians. As we take a look at the unit circle, the cosine value that we're looking for is negative. So we know that we need answers in quadrants 2 and 3, because that's where the cosine values are negative, between 0 and 2 pi. So that tells us where your answers are going to fall. Well, cosine is 1/2. We know the reference angle is 60 degrees, or pi over 3. So in quadrant 2, we can call that angle, we'll have theta equals 2 pi over 3. And the angle in quadrant 3 with a reference angle of pi over 3 is 4 pi over 3. So again, both of those have reference angles of 60 degrees or pi over 3. We got that because the cosine of 60 is 1/2. From there, you're finding in radians the two angles where that's true in quadrants 2 and 3, since that's where cosine is negative. As we saw here, this is a quick checkpoint. First of all, section 8.1 is called simple trig equations. Section 8.5 is actually called more difficult trig equations, so we will build on these. But as we saw, we're often going to have more than one answer between either 0 and 360 or 0 and 2 pi. Those would be the two most common domains that we see. We're going to solve these functions, as we'll see in the next few slides, by isolating the trig function, or getting it by itself, and then eventually taking an inverse. So we'll try a couple of these in degrees. So we see that our domain here is from 0 to 360. That means that all of our answers need to fall within that window between 0 degrees and 360 degrees. We said our first step was to isolate the sine theta, or the trig function, whichever it is. In this case, it's sine. So if we do that, we get sine theta equals -4/5. Now in order to solve for theta, this is where the inverses are going to come in. We're going to take the sine inverse of -4/5. When I plug that into my calculator, I get -53.13 degrees. That means that my reference angle, which we talked about at the beginning of Chapter 7, is the absolute value of that. Since it's negative, we're still just going to treat that as 53.13 degrees. So that's going to be important moving forward. Since we took the sine inverse of a negative value, we know that sine is negative in quadrants 3 and 4. So we know that's where our answers need to be. So what I need to figure out are the angles in quadrants 3 and 4 that have a reference angle of 53.13. To get that angle in quadrant 3, I'm going to take 180 and add 53.13. To get it in quadrant 4, I'm going to take 360 and subtract 53.13. So my answers are 233.13 and 306.87. So it's very important to know how to get the angles in each quadrant with the given reference angle. Your calculator will help you get the reference angle, but not the other answer, so you'll need to be able to do that on your own. If we take a look at the second problem, it has a secant in it. We know the first thing we want to do is isolate that. So we know that the secant of theta equals 11 over 8. We don't have a secant inverse button, so this is where the cosine is going to come in. We know we could also write this as 1 over cosine equals 11 over 8. If I just flip both sides, and this strategy we're going to use a lot, if I make this a cosine theta, I can flip the other side as well, and that can be 8 over 11. At this point, we can then take the cosine inverse of 8 over 11. Since we're taking the cosine of a positive, we want answers in quadrants 1 and 4 because that's where cosine is positive. And when I plug that into my calculator, I get an answer of 43.34 degrees. Now, since I want an answer in quadrant 1, that's it. So we don't have to do any work for that one. We also saw in our green example up here, to get an angle in quadrant 4, we take 360 and subtract 43.34, or whatever our reference angle is. And in this case, our second answer, it gives us 316.66 degrees. So there's a couple examples in degrees. We'll take a look at another couple in radians to see what that looks like. One thing I want to touch on before we get started in radians here, your calculator is going to give you answers, sorry about that, in decimals and not pi form. So it's important to realize that we know that pi is 3.14 or around there. And we'll keep in mind that pi is 6.28. That'll help us in solving some of these. So in this first, and that gives us 2.41 radians, which is our answer. So some of these look a little misleading because of the decimals. We'll do most of these problems in degrees, but that's how it works. You want to keep in mind that 3.14 and the 6.28 are what you're going to use here when you're trying to go from quadrant to quadrant. If we take a look quickly at this next example, we divide by 9, we get the cosine of x equals 13 over 9. What hopefully you'll notice here, we know that sine and cosine values have to be between 0 and 1 because they're on the unit circle. So since 13 over 9 is greater than 1, we can say this is no solution. If you punch this into your calculator, it would give you an error message, so that'll be a good tip-off for that. And the last one we want to take a look at, logs aren't coming back too much, but they will a little bit, some of the simpler ones. If we remember our loop here, we can do this. I can say that 3 to the 0 equals cosine of theta, or 1 equals cosine of theta. That's asking me from 0 to 2 pi, where's the cosine equal to 1? In this case, normally I'm going to change something here. This will really be a greater than or equal to. So if this is just less than, as we'll see it most of the time, since we're not including 2 pi, but we are including 0, your answer is just going to be 0 radians because that's where cosine is 1. So you'll get plenty of practice in class. There's a couple different types of problems that combine a little bit of algebra, like square roots and absolute value, which you've seen before. But these aren't too bad. Just remember, always look for that second answer because there are usually 2.